sum limit as n goes to infinity, I equals 1 to n. We'll say f of c sub I times delta x. What does this mean, guys? What does this mean? If you see that, you gotta really quickly, I'd be able to identify what does this mean. Okay, so it's the area under the curve. Now, when we say area under the curve, what happens if that curve dips below the x-axis? Is it from under the curve down to negative infinity? Or what is it then? Yeah, but between the curve and the x-axis. Let's say that. Between the curve and x-axis. From what? Think about what we would plug in right here. And we could say the curve, and we also could say like f of x, right? The curve is f of x. The area between f of x and the x-axis. Yep. From what? Well, what are the x values in this case? We don't know them, obviously, right? Huh? From A to B. Generally speaking, right? We kind of want to put numbers to it or be more specific. So generally speaking, this means the area of the curve, well, from f of x between the x-axis and the function from A to B, right? So when we see this, that has to drive us to do something, find the area in the curve, okay? And then what did we learn also last week? Well, we learned this thing, A to B, f of x dx, means the exact same thing. Okay, sum I equals 1 to n. F of, now let's go a plus b minus a over ni times b minus a over n, right? Okay, this thing is called a definite integral. Okay, why is this called a definite integral? Because we have bounds. We have a lower bound of a, upper bound of b. So this is called a definite integral. We have a defined boundary at which we are finding the area in the curve. Okay, this would be the antiderivative also. Okay, it's an antiderivative, which we'll get more into that after we get done with just looking at areas. Okay, so this is a definite integral from a to b, f of x dx. This is a more concise way of writing all of this, right? Well, these two things are equal to each other. This is finding the area using the limit process. We want to get to a point where we can find the area a lot quicker. This limit process kind of takes a while, right? And we will get to that, okay? Questions on that? So if I say antiderivative or integral, this is the integral sign. Lower bound, let's call it 1. Upper bound, let's call it 2. 2x squared dx. What does this mean? It means find the area between the curve and the x-axis of the function 2x squared from x equals 1 to x equals 2, right? Graphically speaking, we can make an extremely rough graph. 2x squared, that'd be what, 0, 0, and then 1, 2. And then, okay, 2 squared is what, 4 times 2 is 8. So it has that vertical stretch. And we're going from 1 to 2. We're finding this area under the curve. Now later, when we know how to find the antiderivatives, we don't have to use the limit process. But until then, we have to use the limit process. So let's figure it out. And no calculators, please, right now. Because obviously, you guys know how to type this in. We went over it last week. You can find this answer really quickly. Okay, so this would be what? The limit as n goes to infinity, the sum of I equals 1 to n. Okay, f of, let's see here. Okay, a is what? 1 plus b minus a, 2 minus 1 over n I times 2 minus 1 over n. Obviously, we could simplify this a little bit. And honestly, we could substitute this in to function f. But I like this intermediate step because this gets kind of complicated sometimes. Okay, rewrite, keep going. Limit n goes to infinity. Sum I equals 1 to n. Okay, that would be 2 times 1 plus 1 over ni squared over 1 over n. All right, keep going. We know 1 over n can go in front of the sigma. I wanted to have the lower bound something other than 0 since we will have this here. Okay, honestly, we could put this 2 out in front too, couldn't we? Let's do that. Okay, so we're squaring a binomial, so that'd be 1 squared plus 2 times this, which would be what? 2 over ni plus the b term squared, which would be 1 over n squared I squared. Since we have more than one term in the argument of our sigma, I'm going to put parentheses around it all. Limit n goes to infinity, so it'll be 2 over n. Okay, now let's kind of like distribute your sigma to each term. I equals 1 to n of 1. Sigma I equals 1 to n of, okay, 2 over n can go in front, and then of I. And then the 1 over n squared can go in front. Okay, this stuff's not too bad, is it? Okay, baby steps, take your time, write everything out. That is kind of annoying. I understand that. As a student, I would think this is too much writing. And I'd whine about it because we're teenagers, right? Okay, 2 over n. This would just be 1n. And I don't like writing that because it looks like natural log. N plus 2 over n times, what's the sum from I equals 1 to n of I? Okay, n times n plus 1 over 2. And then 1 over n squared times I squared. Okay. I'm a little worried about that. I want to get everything correct. I'll take this like 5 seconds to write everything out again. And I'm not even going to cancel. I'm just going to leave it unsimplified. So it'll be 2n over n plus, what would that be? Okay, that'd be 4n, n plus 1 all over 2n squared. Plus, and that'd be 2 over n, would be 2n, n plus 1, 2n plus 1 over 6n cubed. All right, now find your limit. Okay, as the angle is to infinity, powers top and bottom on this one are the same, so ratio of coefficients, that'd be 2. That'd be 4n squared eventually if we multiply this all out, over 2n squared. And so that'd be 2 again, right? 2n times 2n again. This 2n right here is the one people forget. And so we have 4n cubed over 6n cubed, which would be 4 over 6, so 2/3. We good so far? All right, what was that? 4 2/3, so it'll be 14/3. And if we're asking for area, that would be unit squared, correct? Okay, calculator, you guys get the same thing? If you check it real quick, use your Math 9, either that or type in your function into y1, and then use your calculate feature. I think it's calculate 7, correct? Check our work real quick. Nice little 10-minute problem. Obviously, if we weren't explaining it or talking our way through it, this could take us 2 minutes, right? Confirmation? Yeah? Good. Awesome. Always feels good when we get these problems right. Big idea. This definite integral means this limit as n goes to infinity of our sum. Okay? Find the area under the curve using the limit process. All right, I think we're good with this. Let's move on to the next topic. Let's draw, again, a random graph. I have no idea what these answers are going to be. It's kind of fun that way. Call this -1, -2, -3, 4, 5, 6, 7. Okay, let's put a point at -3, -1. And let's go connect -1, 0. Let's connect this one. Let's go straight across here. And let's do a arc. Well, that is horrible. Okay, we'll call this f of x. So we have this, and this is straight right here, and this is an arc. This will call us a quarter circle, okay? Now they're going to give us some questions. They're going to say antiderivative 0 to 4 f of x dx. They'll give us this graph. They'll give us this definite integral, and they'll say, what's the area of the curve? That's what it means, right? That definite integral, when given a graph, it means what's the area of the curve. Now, can we use a limit process on this one? What do you mean, yes? Why? Well, so then we can't, right? Okay, if they don't give us a formula for f of x, we can't use the limit process. We just got to find the area of the curve. Well, guys, we all took geometry, right? We all know how to find the area of geometric figures. That's all you do. Okay? 0 to 4, what do we got? Okay? Analyze what you have in that graph. Okay, it looks like we have a square from 0 to 2. Okay? We have a square from 0 to 2. What's the area of that square? Okay, 4. I'm just going to go 2 times 2. Plus, okay, from 2 to 4, we have a quarter circle, right? Okay, so it'll be 1/4 of, what's the area of the circle? Pi. What's r in this case? 2 squared. Okay, we okay with that so far? Not too bad, huh? All right, then let's leave everything exact, please. So it'll be what? 4 plus 1/4 times 4, that's 1 pi. So 4 plus pi unit squared would be the area of the curve. Well, check this out, guys. We just broke up this antiderivative from 0 to 4 to 0 to 2 plus 2 to 4. And it actually works that way. That's what property we're going to learn later. I'm showing you now, though, so we can skip it and go through it quicker later. Whoops, dx. That's the same thing as the antiderivative 0 to 2 f of x dx plus antiderivative 2 to 4 f of x dx. So basically, we kind of discovered this, finding the areas geometrically. Okay, what's the area from -1 to 4 f of x dx? Well, that would be the area from -1 to 0 f of x dx plus 0 to 4. Why am I breaking up like this? We already know this area, right? We already know this area. Why do we need to find it again? Okay, what's the area under the curve from -1 to 0? That's a triangle, right? So 1/2, base is 1 times height of 2, so 1 plus 4 plus pi. So that'd be what, 5 plus pi? Unit squared. You know what I like to do when I'm doing these, especially if they get asked a whole bunch of questions about the same stuff? I like just to come up here and say, okay, this is area 4, this is area pi. I like to break it up because just in case I have to do this again. This is area 1, right? Okay. I think you guys know which one I'm going to ask next, don't you? Antiderivative. What am I going to put right here? -3. 2, 4. Okay. Well, what's the big idea about this triangle right here, guys? Same area as this, but it's negative. So what I like to do is, since I know this area is below the x-axis, I just put a negative sign in front of it right away so I don't accidentally add it. Okay, so -1/2. Okay, then we have base, which is 2, height, which is 1. And then, honestly, we don't have to write this broken up. I know this is just the sum of all the areas. We can just write the sum of all the areas, right? +1, +4, plus pi. Or I could have just wrote this one down too, okay? So that would be -1 plus 1 is 0, 4 plus pi. Units squared. Let's draw another random one. Let's see here. Let's go -1, 2, 3. Let's see, what do you want? Triangle or square?
Square.
Square, okay. We'll call it a rectangle. Terrence, what do you want? Geometric figure. You want a trapezoid? You want a circle, semicircle, quarter circle? A circle? That'd be tough, though. Semicircle? That's going to look kind of stretched out because my vertical scale and my horizontal scale are a little different, the distance between them. Okay, semicircle. Triangle? What do you want? Rectangle? Let's go. Yeah, let's go like this. Now what? A cubic? Oh my goodness. Actually, we don't need that. Okay. Now, obviously, this would not be like a function. Just pretend this line is not right here. Okay. Let's just pretend that one's not there. We'll call this g of x. This is the function g of x. This is going to be fun. Let's find, integral. Let's go -2 to 1 g of x dx. See what you can do. Well, the center is at -2, +2. This one? Okay, what did you mark it in your graph, or what'd you do? Did you write it over here or over here? Okay, what's that area then? -3? So you went like -3 here somewhere. I actually like to go left to right, and sometimes if it's a graph, I'll sketch on here. I'll go like that, or I'll go like this and like this. So I remember to find all the areas. So I think some of us, we might find the area of this quarter circle and forget to add on this area of the square or rectangle, right? Adam, what'd you do next? What'd you do next? This whole thing? Okay, give me some numbers. Okay, leave me some numbers.
So
2 plus 1/4 pi. And then r squared, so 1 squared, right? So this would be the 1/4 pi would be this guy, right? And what's the 2 come from? So you kind of went like this. You got 2, and you got 1/4 pi right here. Is that right?
Yep.
Okay. Nora, what do you got next? What's the area of this triangle? Are we okay with that? So we have 2 plus 1/4 pi plus 1 minus 3. And that's just 1/4 pi. Is that it? Is that what you guys are getting? Okay. So this rectangle cancels out basically this rectangle and this triangle. All right. Now, if I went, let's just think about this for a second. -2, 1, oh, not 1. -2, 3. G of x dx. Would this answer be more or less than 1/4 pi? Less than why? So you're adding negative values, right? So the quantity should be less than, so we can kind of figure out the reasonableness of our answer, right? Now, if we went, from -4 to +3, would all of this cancel out all of this? Highly unlikely, because we have the pi up here, right? So it's not going to be exact. That'd be fun to calculate if we wanted to. And I don't want to, because I want to stop right here. Any questions on this?